Our dear viewers, good morning. I'll not get tired of reminding you guys to always be thankful to God. God has kept us alive, and we are very hopeful that come September, God willing, we might go back, okay? Last week, we were still looking at some of the chemical properties of chlorine. And I remember I left you with a question. And I'd explained most of what that question wanted. And I told you after explaining the bleaching action of chlorine water, I went to the most immediate examinable part apart from that bleaching action. And that was what would happen if that chlorine water was exposed to sunlight, or effect of sunlight on chlorine water. And I drew for you the setup, what you observe, and I wrote for you two equations. But the question I left you with had only to state the observation, you explain your observation, and then write an overall equation. Remember, in my explanation, I used two equations. But a question may come whereby they require only to write one equation. So we're looking at some of the chemical properties of chlorine. And we're looking at what happens when sunlight is exposed to a test tube containing chlorine water. And I told you, how do we get that chlorine water? By simply passing chlorine gas into a beaker or into a flask or into a conical flask containing water. And I told you what would happen. Our colorless solution, which is water, our colorless liquid, will turn to a pale yellow solution coming from the color of chlorine gas. So what really takes place, remember we are saying, the question that I left you with, it was explain what would happen if a beaker containing chlorine water was exposed to sunlight. And what was our observation? Our observation was that a colorless solution, let us start from where? Okay, a pale yellow solution turned to a colorless solution but with bubbles of a colorless gas. With bubbles okay, that is our observation. We observe that a pale yellow solution turned to a colorless solution but with bubbles of a colorless gas. And the bubbles of a colorless gas are standing in for the oxygen gas. That was the observation. But now part B of that question was explain your observation. Okay? The pale yellow solution is standing in for chlorine water. But when you remember chlorine water, these are the two equations that I wrote for you. Okay? That is our chlorine water, which is a mixture of those two acids. And I told you on exposure to sunlight, what happens? The hypochlorous acid that is formed, this is our hypochlorous acid. The hypochlorous acid that is formed is a very reactive compound. When you expose it to sunlight, what happens? It decomposes. It decomposes. It decomposes to give you what? HCl plus our chlorine plus our oxygen gas. We balanced the equation by multiplying here with 2, by also multiplying here with 2. So those are the two equations that really take place. Okay? So what would be the explanation? The explanation would be that chlorine water, okay, is a pale yellow solution. Okay? And it is a mixture of hydrochloric acid and then hypochlorous acid. Okay? But the hypochlorous acid that is formed is a very, very reactive compound that when exposed to sunlight, it decomposes to give HCl and then our oxygen gas. So what does that mean? It is the decomposition of this gas that will give you, that will enable you to form HCl and then oxygen gas. So that is what was needed in your explanation. Okay? So that's why you're able to observe now a colorless solution but with bubbles of a colorless gas. But now the next question was, write an overall equation. Writing an overall equation, I'm just teaching you this. We had two equations, but we are going to solve these equations simultaneously from your math. By senior 4, you've looked at those equations, solving equations simultaneously. Therefore, it means that, remember, this was our reactant, that was chlorine reacting with water to give us a mixture of those acids. Okay? Therefore, it means that what is going to act as our intermediate is that hypochlorous acid. And what are our products? Our products are going to be these. Therefore, what do we do? In solving these equations simultaneously, we look out for a compound that we are going to eliminate. And which compound are we going to eliminate? This time round, we are going to eliminate hypochlorous acid. So these will act as our reactants, and these will act as our products. Therefore, what do we do? To eliminate hypochlorous acid, what does that mean? We make sure that the hypochlorous acid this side and this side balances. And how will it balance? By multiplying this equation with what? With the 2. Therefore, how many equations have you come up with? Now you have 2 moles of chlorine gas plus what? Plus 2 moles of water to give us what? To give us 2 moles of HCl plus 2 moles of hypochlorous acid. We want to solve these equations simultaneously. But we are going to get rid of the hypochlorous acid. Since they are on different sides, when you look at this equation, here it is acting as a reactant. Here it was a product. We simply sum up those 2 equations so that we can come up with the overall equation. What will our overall equation be like? Okay? The reactants we have, okay, 2 hypochlorous plus 2 moles of water plus 2 moles of chlorine gas, giving us what? Giving us this plus this, therefore, plus 4 moles plus 1 mole of oxygen plus 2 moles. Okay? That is our overall. But remember, in chemistry, if what appears, if you are solving these equations, even from math, you have 2 moles of hypochlorous acid here, you also have 2 moles of hypochlorous acid the other side. Therefore, it means that they are going to cancel out, because as this one goes the other side, it will acquire a negative sign. Therefore, it means that now the hypochlorous acid will be removed. And therefore, we shall have 2 moles of water plus what? 2 moles of, giving us what? Giving us 4 plus that. I've written all this because I wanted to show you how I come up with the overall. This is our overall. That is our overall. If the question had come, a test tube containing chlorine water was exposed to sunlight. Question 1, state what was observed. Part B, explain your observation. Part 3, write an overall equation. This is what the examiner wanted. When you write these 2 equations, they will not mark you. You'll score nothing. Because for us, when we're marking, whatever we meet first is what we mark first. Therefore, if they were asking for the overall and you wrote this, it means that this is what the examiner meets first. And therefore, this is what the examiner is going to mark. Okay? And therefore, you'll get nothing. So our overall is here. But there are cases whereby the question comes and they are saying a test tube containing chlorine water was exposed to sunlight. Okay? State what was observed. Explain your observation. And then part B, part C, write equations. Write equations. They will put S in brackets. Write equations for your observation. It means that in such a scenario, 2 equations are needed. The first equation of forming a mixture of chlorine reacting with water to give you HCl and then hypochlorous acid. Then the second equation will be the hypochlorous acid decomposing to give you HCl plus oxygen. Please note, if the question wants equations, it means that you must write this equation when you have not multiplied, okay? Write this equation, you also write this equation. But if it is asking for an overall equation, it means that this is the overall equation. And I've told you, how do you get the overall equation? By getting the 2 equations and solving them simultaneously. That is from the math bit of it. And by senior 4, you would have looked at those solving equations simultaneously. So that is what our question wanted. This is our overall equation. Our observation is that I said the explanation is going to be chlorine water, okay, is a mixture of hydrochloric acid and then hypochlorous acid, okay? And it is a pale yellow solution. But when exposed to sunlight, what happens? The hypochlorous acid formed is a very reactive compound. What happens to it? It decomposes to give you HCl, hydrochloric acid. Remember, you're not using symbols. To give you hydrochloric acid and then oxygen. That's why the solution now turns out to be a colorless solution, but with bubbles of a colorless gas. Okay? So that is what we wanted. That is what the question wanted. Okay? So, the bleaching action of chlorine, I did it. Okay? Effect of sunlight on chlorine water, I've also done it. And I've done it perfectly. So that is what we wanted. Let us go to the next chemical reaction of chlorine. There are cases whereby chlorine is going to act as an oxidizing agent. And I told you for you to understand this part very well, you must know what oxidation is and what reduction is. You must know oxidation. You must know reduction. So whenever we meet these two words, there are three things we must always think of. We can define oxidation in terms of oxygen, in terms of hydrogen, in terms of electrons. The same applies to reduction. So what is oxidation? Addition of oxygen. What is oxidation? Removal of hydrogen. What is removal of electrons? Okay? Reduction. Addition of oxygen. Sorry, addition of hydrogen. Okay? Addition of electrons. And this will be removal of oxygen. So when you look at these three definitions of these two terminologies, you get to understand, or you get to believe, that oxidation is the reverse of reduction. Oxidation is the reverse of reduction. What is oxidation? Addition of oxygen to a substance. What is oxidation? It can also be removal of hydrogen from a substance. What is oxidation? It can also be removal of electrons from a substance. What is reduction? Addition of hydrogen, addition of electrons, or removal of oxygen from a substance. So sometimes the reactions we look at, they will necessitate us to use either electrons, or to use hydrogen, or to use oxygen. So what must we understand? After understanding the definitions of the two terminologies, then we must understand what is an oxidizing agent. What is an oxidizing agent? What is a reducing What is a reducing agent? An oxidizing agent is a substance that oxidizes the substance it is reacting with, but itself, it undergoes reduction. What does it do? It oxidizes the substance it is reacting with, but for itself, it will undergo reduction. Therefore, it means that an oxidizing agent will either add oxygen, or remove hydrogen, or remove electrons from a substance it is reacting with. But itself, it will be reduced by addition of hydrogen, or addition of electrons, or by removal of oxygen from itself. So an oxidizing agent undergoes reduction, but it oxidizes the one it is reacting with. A reducing agent, it undergoes oxidation. It undergoes oxidation, but it reduces that element or that substance it is reacting with. So you must understand these terms very well. An oxidizing agent undergoes reduction, but it oxidizes the one it is reacting with. A reducing agent undergoes oxidation, but it reduces the one it is reacting with. So we are going to look at the chlorine acting as an oxidizing agent. Chlorine acting as an oxidizing agent. Under what scenarios does chlorine gas act as an oxidizing agent? Under what scenarios does chlorine act as an oxidizing agent? At your level, I'll only look at two. The other scenarios, you will see them at a higher level. I'll look at only two. When chlorine behaving as an oxidizing agent. I'll look at one. When chlorine gas is bubbled through salts of iron 2. Salts of iron 2. Okay? Or when chlorine gas is being reacted with another gas, which is hydrogen sulfide gas. So, whenever you bubble chlorine gas through iron 2 salts, okay, what happens? What happens? Iron 2 salts. Okay, the iron 2 salts will be oxidized to iron 3 salts. And what will happen to chlorine itself? It will be reduced to chloride ions. Iron 2 salts, they can give you iron 2 chloride. Iron 2 chloride solution. Remember, iron 2 salts in solution form, they are pale green. And iron 3 salts are yellow in color. Therefore, when chlorine gas is bubbled through a solution of iron 2 chloride, okay, what do you observe? You observe that a pale green solution turns to a yellow solution because these iron 3 are yellow in solution. They will be reddish brown when they come out as precipitates, but in solution they turn out to be yellow. So whenever you bubble chlorine gas through a salt containing iron 2, it will be oxidized to iron 3. Therefore, what do you expect? You expect that a pale green solution, which is the color of iron 2, will turn to a yellow solution. The yellow solution, the yellow is for the iron 3. So they may ask you, the question may come, write an ionic equation. Or the question, they may specify for you the salt, the iron 2 salt. And the question is just comes, write an equation that takes place. There you're free to write the molecular equation, you're free to write the ionic equation. But I'll teach you both because you never know. Sometimes the question may come and it is very specific. Write the ionic equation. And it means that when they say write the ionic equation, and you write the molecular equation, you will be marked wrong. But if the question just comes, write the equation, whether it is an ionic equation or a molecular equation, any will be marked. So, for example, what would happen if iron 2 chloride, to a solution of iron 2 chloride, chlorine gas was passed? You remember your observation is going to be that the pale green solution turns to a yellow solution. What will be your explanation? They may ask for the explanation simply because iron 2 is being oxidized to iron 3 by chlorine gas. So if I had this salt, which was iron 2 chloride, okay? And then I added chlorine gas, okay? What am I expected to form? I'm expected to form iron 3, the most stable oxidation state of iron. I'm expected to form iron 3. But I've kept on telling you this, that however neat your symbols may be, without these equations being balanced, you will be wasting time. please, whenever you see that you have not balanced the equation, just know that you will not score anything. So let us balance this equation. We have 4, we have 3. If I multiply with a 2, it means that the iron atoms have become 2. Even this side here, I'll multiply with 2. These are 4 plus 2, then it gives us a total of what? 6. On the other side, 4 chlorine atoms. So this is our molecular equation. If that given me iron 2. If that given me iron 2 chloride. But I can use this to form the ionic equation. Molecular equation. But if I wanted to form the ionic equation, okay, and remember, when do we form ions? When do we form ions? We form ions either in molten state or in aqueous state. We don't form ions in gas state or in liquid state. Therefore, what ions am I going to form? I'll have iron 2 ions this side. Okay, aqueous, because this is aqueous. But how many are they? They are 2. Okay, I have 2. I also have my chloride ions. Okay, remember those chloride ions have a valence of 1. They are anions. But how many are they? They are 4. And what do I get? Plus my chlorine gas. Remember, I've told you we don't form ions in gaseous state, we don't form ions in liquid state, and also we don't form ions in solid state. We shall only form ions either in aqueous state or in molten state. Therefore, what do I form? I'll form my iron. Iron what? Iron 3. But how many are they? They are 2. Okay? And my chloride ions. But how many are they? They are 6. But remember, we said we look for those ions that are identical. And if they can be reduced, you reduce them. If they can be gotten rid of, you get rid of them. If they can be added, you add them. Okay? So here I have iron 2. Here I have iron 3. Therefore, there's no way I will get rid of iron 2. Therefore, I will have iron 2. Okay, there are 2. I have 4 chloride ions here. I have 6 chloride ions here. It means that I can get rid of them by taking this the other side. Okay, when I take it the other side, it means that now here it will cease to contain the positive charge. It will have now a negative charge. Therefore, it means that this side here I will remain with my chlorine. Okay, giving me what? Giving me iron 3. Okay, aqueous. Okay, 6 minus 4 plus what? Plus 2 chloride ions. So what will my ionic equation look like? I was only showing you what really takes place. That is our ionic equation. Okay? Iron 2 has been oxidized to iron 3. Okay? Chlorine has been reduced to chloride ions. And one would ask that, Madam, now how do you know that it has been oxidized? Let me explain that very fast. Okay? We have iron 2. Giving us what? Iron 3. But remember, we said in oxidation, you're either adding oxygen or removing electrons or removing hydrogen. Okay? It means that what will the oxidation reaction look like? We have iron 2, but since iron 2 is being oxidized by chlorine, therefore it means that here we are going to talk in terms of what? Electrons minus an electron, giving us what? Iron 3. Remember, the total charge here and the total charge here must be the same. Okay, so how will this equation be written? Like, it will be iron 2, okay, giving us what? Iron 3 as the electron comes this side. Okay, what does that mean? You have a positive 2 here. Here you have positive 3 plus negative 1, because remember electrons are negatively charged. You'll also have positive 2. Therefore, it means that indeed, iron 2 has been oxidized to iron 3. They may ask for that. They may give you that equation, and then they say, write the oxidation reaction. Write the reduction reaction. So this is an oxidation reaction. Iron 2 being oxidized to iron 3. Okay, what about for chlorine? Has it really been reduced? Remember, we have chlorine gas, but now giving us what? Giving us 2 chloride ions. And what do you remember? Remember, we said that when it comes to reduction, what do we have? We have removal of oxygen, addition of electrons, or addition of hydrogen. It can be removal, it can be addition of hydrogen, it can also be addition of electrons. Therefore, here you have a net charge of -2. But here you have a charge of what? 0. Therefore, it means that what has really taken place, we must add how many? We must add 2 electrons. And therefore, our equation is going to be that. Okay? The number of electrons that you get will come from the total charge here. I had a total charge of -2, that's why I added 2 electrons here. Here, remember, I had +2, okay? In this, I had +2, and I had +3. Therefore, it means that +2 is less by +3 by 1. That's why I subtracted only 1 electron, because oxidation is the removal of electrons. Therefore, in our redox reactions, we shall see in terms of addition of oxygen, in terms of electrons, or in terms of hydrogen. So that is what takes place when chlorine is acting as an oxidizing agent to iron 2 salts. They can give you iron 2 chloride, they can give you iron 2 sulfate, okay, or iron 2 nitrate. Are you getting it? So it means that there you must be very keen. Iron 2 will be oxidized to iron 3. And I always tell my students that it is better for some of these reactions to write the ionic equations. They are very simple. You really get to balance them very fast. It's better to write the ionic equations than the molecular equations. Therefore, that was scenario 1. Iron 2 to iron 3. The observation, pale green solution to a pale green solution to a yellow solution. Okay? Explanation is simply because chlorine gas oxidizes iron 2 to iron 3. Okay? And iron 2 salts are pale green in solution, and iron 3 are yellow in solution. I told you when they come out as precipitates, they're reddish brown. They're not yellow, they're reddish brown. But in solution, they are yellow in color. Okay? So that is scenario 1. Scenario 2, when it is reacting with hydrogen. Sulfide. That is a gas. This gas, some of you have gotten it. Like when you look at the rotten cabbage tends to give out that hydrogen sulfide with an irritating smell. So hydrogen sulfide, that is hydrogen sulfide, And one would ask, when do we get sulfides? When metals or nonmetals react with sulfur, the compounds that you form are called sulfides. This is coming from the valence of sulfur. Remember, hydrogen has a valency of 1. So when you bring two gas jars, one containing chlorine gas, another one containing hydrogen sulfide, and you let the gases mix, what are you going to observe? You're going to observe that one. Remember, we said chlorine gas is greenish yellow in color. That color will continuously fade away. It will disappear. But again, what are you going to be left with in that reaction flask where you let the gases react? You're going to be left with mist fumes, and then you're going to form a yellow solid. So when we have chlorine gas, our equation, we have our chlorine gas being reacted with hydrogen sulfide. And what are we expected to form? Remember, we are saying this is acting as an oxidizing agent. And this time around, it's going to act as an oxidizing agent by removing hydrogen from hydrogen sulfide. Therefore, what are you left with? You're left with sulfur, because it has oxidized the hydrogen sulfide by removing the hydrogen. But itself will be oxidized, itself will be reduced by combining with the hydrogen. So that what do you form? You form HCl. You form HCl. Okay? So this is what you form. Chlorine has oxidized hydrogen sulfide by removing hydrogen. Therefore, what are you left with? You're left with sulfur. Itself has been reduced by combining with hydrogen to form, by reacting with hydrogen to form HCl. Let us try to balance the equation. How shall we balance the equation? I told you always and always balance your equations. We have 2 hydrogen atoms. We also have 2 chlorine atoms. Therefore, we simply multiply with a 2. And this is a non-metal, but yellow in color. Okay? So what do you observe? You observe that the greenish yellow gas gradually disappears, leaving behind a yellow solid. And sometimes you can also talk of the misty fumes or the steamy fumes of hydrogen chloride. And that is what you write, and that is what you observe. And the explanation for the observation will also be very simple. That chlorine gas oxidizes hydrogen sulfide by removal of hydrogen, okay, forming sulfur, and itself has been reduced by reacting with the hydrogen to form hydrogen chloride. Therefore, at your level, we shall look at those two. We shall look at those 2 equations as some of the reactions whereby chlorine is acting as an oxidizing agent. But at higher levels, for some of us who are going to continue with chemistry at A level, we shall look at more numbers. But for your level, those 2 examples are enough. Scenarios whereby chlorine is acting as an oxidizing agent. Those 2 examples are enough. The next chemical property is going to be what happens when chlorine gas is being reacted with hydrogen gas. Remember, when you're looking at the periodic table, what did we say about the periodic table? We said when it comes to group 7, 1, they are the most reactive nonmetals. But we said, though they are the most reactive nonmetals, their intensity of reactivity is not the same. We said what happens? Reactivity decreases down the group. What happens? It means that fluorine is the most reactive, followed by chlorine. Therefore, the reaction of chlorine with fluorine is very explosive. But the one of chlorine with hydrogen is spontaneous, or it is vigorous. So chlorine gas, when reacted with hydrogen gas, the reaction occurs vigorously, very fast, because remember we have said chlorine is the second reactive nonmetal in group group 7. So it will react spontaneously, and in most cases in presence of UV light. It will react spontaneously in presence of UV light to give you steamy fumes or to give you white fumes of hydrogen chloride gas. And this is one of the ways through which hydrogen chloride gas can be manufactured on a large scale, by simply let those gases react, but one being prepared from a large scale, another being prepared from a large scale. When you let them react in presence of UV light, you will form HCl gas, but on a large scale. We shall see on a small scale, that is in the laboratory setting, how do we prepare it. But on a large scale, we shall basically use this. So reaction of chlorine gas with the hydrogen gas. And I've told you, what must you note? The reaction occurs vigorously, very fast. To form what? To form white fumes of hydrogen chloride gas. So what will our equation be like? Our equation for the reaction, we shall have hydrogen gas, which is diatomic, in being reacted with chlorine gas, which is also diatomic, and presence of UV light, giving us what? Giving us HCl gas. Please balance the equation, and then that's how you'll balance the equation. And that is what really takes place. Those come out as white fumes, that is, or mist fumes. That is our HCl gas. Okay? So we are left with one equation. One equation. Okay? Affinity. Affinity of chlorine gas for hydrogen. Affinity of chlorine gas for hydrogen. One would ask, isn't it the same like this? No. No. Whenever you're reacting chlorine gas with a compound that has hydrogen, it tends to have high love. It has that love. It tends to abstract. It tends to abstract the hydrogen from that compound. And it will combine with the hydrogen, and it will leave the other part behind. So it means that chlorine has that high love for hydrogen. Whenever it meets a compound that has hydrogen in it, it tends to take away the hydrogen, and you leave behind the other part of that compound. So that is what that subheading is trying to mean. Affinity of chlorine gas for hydrogen. Chlorine has high affinity for hydrogen. It tends to abstract the hydrogen from compounds that contain hydrogen, leaving behind the other part of those compounds. So, and the best example we basically talk of turpentine. Turpentine, which is a hydrocarbon. Turpentine, which is a hydrocarbon. Remember, we said from our organic chemistry. From our organic chemistry, we said a hydrocarbon is a compound made up of carbon and hydrogen only. So turpentine is a hydrocarbon. A hydrocarbon which is made up of what? Carbon 10, hydrogen 16. That is our turpentine. Sometimes the examiners are so lenient with you people that they also get to know that maybe you've forgotten the chemical formula for turpentine. And sometimes when they set these questions, they put for you the chemical formula in brackets. But sometimes they may not want to know. They may not write for you the chemical formula, but you need to remember what is the chemical formula for turpentine. It is a hydrocarbon with carbon 10, hydrogen 16. And I told you when it comes to affinity of chlorine gas for hydrogen, it tends to abstract away the hydrogen and it reacts with it, leaving behind the other part of the compound. And which other part of the compound will it leave behind? It is going to leave behind carbon. But as I've just explained with the reaction of chlorine with hydrogen, this reaction is so vigorous. It is very violent. So this reaction occurs violently, okay? But what do you leave behind? You leave behind black particles. And the black particles are standing in for carbon. Remember, carbon is black in color. The good example of carbon in our homes, that is charcoal. That is amorphous carbon. It is black in color. So what does that mean? They may tell you to explain, they may tell you to state the observation, and then they may tell you to write the equation. What really takes place? This is a hydrocarbon, which is solid in nature. So what really takes place? We heat it a bit. When we heat it a bit, it will become molten. And in the molten state, we drop there a filter paper. We use the filter papers when it comes to the practical aspect. We drop a filter paper in that molten turpentine, and then it means that now the filter paper will now contain turpentine, but in molten state. So it is the filter paper that now you drop in a gas jar containing chlorine gas. The reaction occurs violently. The reaction occurs vigorously. And what do you see in your gas jar? You'll see black specks or black solid particles of this man here. And what is that man? That man is carbon. What really takes place? That is our equation. We have our chlorine being reacted with what? Being reacted with turpentine. Okay, it has the high level for hydrogen, therefore it pulls away the hydrogen and reacts with it. Therefore, what do you form? You form that, but plus what? Plus carbon. How do we balance the equation? Here we have 10, we multiply with 10. Here, how many do we have? We have 16, therefore we multiply with 16. And automatically we shall multiply with 8. Okay, that will be our equation for the reaction. That will be our equation for the reaction. And it is one of the reactions that we use. It's one of the reactions that we use to show the affinity of chlorine gas for hydrogen. Sometimes instead of using turpentine, they will use burning paper. But we shall see that. Time is not on my side. Let me leave you with these two equations. And as you read more and you practice more using your question bank and other past papers, I think all the chemical reactions and the physical reactions of chlorine have been dealt with. We are only left with uses of chlorine gas. So our question 1, that's asking, calculate the number of moles of hydroxide ions that are found in 7.4 grams of calcium hydroxide solution of calcium. Calculate the number of moles of the hydroxide ions that are found in 7.4 grams of calcium hydroxide solution. You've been so wonderful. I received very many comments. Please continue. I receive your work and I try to mark your work. Please continue reading, practice, but above all, remember to ask whatever you want from the Almighty. Thank you so much, BBS. Thank you so much, Maryland. May the good Lord bless you abundantly.
Somera